BJT bipolar junction transistor is essentially a nonlinear device. To make it linear for analysis purpose, equivalent circuits are used. Several types of circuits, equivalent circuits are available. Some are useful when the signal amplitude is small. Some are useful when amplitude is large. Some are useful when signal frequency is small. Some are useful when frequency of the signal is high. Pi equivalent circuit is one type of BJT equivalent circuit which is useful to represent the BJT when it is working with high frequency signals. Hence, it is a high frequency BJT equivalent circuit. In the circuit, there exists 4 resistors, 2 capacitors, and 1 dependent current source. Count-wise, component count-wise, it is somewhat complex in comparison with the ordinary H parameter low frequency equivalent circuit. The speciality of this circuit is it is valid for all the 3 configurations. It means only one equivalent circuit for all the 3. That is CB, CE, CC configurations. So appropriate terminal is to be grounded and used to represent, to denote the behavior of BJT in the amplifier circuit. It can be used even when signal frequency is small, but its complexity usually prohibits its usage at low frequencies. Already, ordinary H parameter equivalent circuit, which involves simply 4 parameters. That circuit is available, and hence it is not at all wise to use this. But sometimes, if situation demands use of this circuit at low frequencies, then it can be used. Of course, capacitances that exist in the circuit, then they are no more required to be there. So total circuit minus capacitances can be used to represent the transistor when it is working with low frequencies. Apart from H parameter equivalent circuit, pi equivalent circuit, there exists T equivalent circuits also. Whenever it is necessary or appropriate, there one or other equivalent circuit is picked up and used and get benefited. Electronic devices, BJT equivalent circuits, Part 2, Series on Semiconductor Devices and Circuits, lecture number 5.11. BJTs are basically associated with 2 equivalent circuits. One is a H parameter equivalent circuit, another is pi equivalent circuit. The first one is low frequency equivalent circuit, whereas second one is high frequency equivalent circuit. Both are meant for small signal operations, and the second one, pi equivalent circuit, is somewhat complex when compared to H parameter equivalent circuit. In the present session, we focus on pi equivalent circuit of BJT, different parts, different elements that are there in the pi equivalent circuit. Now, we begin the session by considering the equivalent circuit, BJT equivalent circuit. It is called pi model, hybrid pi model. Reason for it being called pi model is that it is in the shape of pi. Pi means two legs, there is a roof, that is pi. Here also one can find two legs, this side, that side, and a roof is there. That's why it is pi. Emitter is common. So this is common emitter configuration. We are going to see this same circuit can be used even for CC configuration also. Of course, in such case, see, collector terminal is going to be the common, but circuit remains the same. Now, there are some resistors RB prime, 1 GB prime E, 2 GB prime C, 3 GCE, 4 resistors or conductances are there in the circuit, and 2 capacitors are there, CE, CC, 2 capacitors, and 1 current source, GM prime E. This is the constitution of a pi equivalent circuit. What is RB prime? What is GB prime E? What is CE? What is VB prime E? What is GB prime C? What is CC? What is GCE? What is GM VB prime E? All these elements of the circuit are explained, described in the next slide or slides. Here is shown another pi model. This is valid at low frequencies. The earlier one shown in the previous slide, it is valid both at low frequencies as well as high frequencies. But the circuit that is shown here in this slide, it is valid only at low frequencies. One can notice the difference between this circuit and the previous circuit. Both are pi models. Difference lies in the fact that in this circuit, capacitances are absent. If we if we remove the capacitors from the equivalent circuit shown in the previous slide, the circuit that is being shown in the present slide right now, it comes into being same circuit, of course without capacitors. Now, parameters that are there in the equivalent circuit, they are described, defined, and discussed also. Most important of all is GM. It is called transconductance. Small changes in the emitter junction voltage V prime E are associated with changes in injected excess minority carrier concentration into the base, and as a consequence, small signal collector current changes in proportion to VB prime E. This effect is taken into account by inclusion of a current generator GM VB prime E in the equivalent circuit. From pi equivalent circuit, since the short circuit current gain is GM VB prime E, the transconductance GM can be defined as GM is dou IC by dou VB prime E. Small change in DC collector current to small change in base to emitter DC voltage while maintaining VC constant. This is definition dou IC by dou VB prime E while maintaining VCE fixed. When we apply the definition to a transistor, then we can found that GM is equal to IC by E, or IC in milliamperes by 26. VT is volt equivalent of temperature. It is 26 millivolts at room temperature. So when that particular aspect is introduced into the expression IC by VT, we will be getting IC by 26 milli, IC in milliamperes by 26. Another parameter is input conductance G B prime E. Any increase in the minority carrier concentration in the base results in an increased recombination base current. This effect is taken into account by including a conductance Gb prime E into the equivalent circuit by definition, or by applying the definition of Gb prime E, one can find that it is equal to Gm by HFE. Of course, Gm is known to us, it is IC by Vt. So Gb prime E is IC by HFE Vt. Another parameter, base spreading resistance RB B prime. The internal node B prime is not physically accessible, and the ohmic base spreading resistance between the external base terminal and B prime is represented as a lumped parameter, RBB prime. HIE is equal to RBB prime plus RB prime E. So this is from the definition of HIE. When applied to pi equivalent circuit, from the definition of HIE, one can get it being equal to RBB prime plus RB prime E. From this, one can say RBB prime is equal to HIE minus RB prime E. HIE is available from the data sheets. RB prime E is already calculated in the previous slide. Another parameter, feedback conductance GB prime C. Due to early effect variation in reverse biased collector junction voltage changes the effective base width, which in turn cause a change in base current, input current. The input current is affected by output voltage, and this feedback effect is taken into account by introducing a conductance G B prime C into the circuit in between B prime and C terminal. C means collector, B prime means internal base. It can be found equal to approximately HRE GB prime E. G B prime C is equal to HRE G B prime E. This is an approximation. Output conductance GCE. It is there on the output side of the equivalent circuit. The output conductance GCE is included in the circuit to account for the feedback effect that exists in the transistor due to early effect. It is defined as the output conductance in between C and E with input open circuited. That is IB equal to 0. So GCE can be shown equal to H0 E minus HFE GB prime C, which is roughly equal to H0 E minus HRE GM. Now whatever we have done so far with pi equivalent circuit parameters, they are all mentioned here at one place, so that it becomes easy to comprehend them, to understand them. Transconductance and resistances. GM is IC by VT. Roughly it is equal to 50 millisiemens. Not only expressions are given here, but also typical values are also given here. GB prime E is GM by HFE. Its value is roughly 1 millisiemen. RBB prime is HIE minus RB prime E is roughly 100 ohms. GB prime C is equal to HRE by RB prime E Nearly it is equal to 0.25 microsiemens. GCE is equal to H naught E minus 1 plus HFE GB prime C. It is nearly equal to 1 over 80 millisiemens. Hybrid pi capacitances. So far, our discussion is about transconductance and other resistances that are there in the equivalent circuit. In addition to these elements, there exists two capacitances also in the circuit. Information regarding those two capacitances, they are provided here under hybrid pi capacitance, CE, emitter capacitance. It consists of two components, CDE plus CTE. D means diffusion capacitance. T stands for transition capacitance. At the junction, notice whether it is forward biased or reverse biased, always there exist two capacitances. One is diffusion capacitance, another is transition capacitance. However, under forward biased condition, diffusion capacitance dominates the transition, and under reverse bias, transition capacitance dominates the situation. The emitter junction is under forward bias. We are considering amplifier. So emitter is under forward bias, therefore diffusion capacitance dominates. CE is mainly CDE. And the CDE can be found equal to GM W square IE by 2 dB. E means emitter current, W is width, dB is diffusion constant. So it can be shown as CE roughly equal to GM by 2 pi FT. This is from dimensions and DC currents, etc. Okay. CE can CE is CDE. This is CDE. Okay. CE can also be shown equal to GM by 2 pi FT. FT is defined as frequency at which short circuit CE current can becomes unity, whose value is typically 80 megahertz. FT, it is an important parameter. FT is equal to F beta HFE, roughly GM by 2 pi CE. Here F beta is equal to GB prime E by 2 pi CE plus CC, which is equal to 1 by HFE GM by 2 pi CE CC. A little bit of analysis is required. Here all those steps are not shown. Only important relations are being mentioned. So whatever being shown, whatever being described here, they are all quite an important thing. The frequency range up to F beta. This is F beta. Typically around 1.6 megahertz is usually called bandwidth of the circuit. Now, in this slide, two slightly different versions of a simplified pi model for the small signal operation of BJT are shown. We have simplified H parameter circuit. Similarly, here we have simplified pi model. Slightly different versions. In A, one model, in B, another model. What is the difference? In both, one resistor is there, one dependent current source is also there. In A, dependent current source is GMVBE, whereas in B, dependent current source is beta IB. Beta carries its own usual meaning. Of course, here GM is IC by VT, R pi is beta by GM. All these things we are already discussed. The equivalent circuit in A represents the BJT as voltage controlled current source, a transconductance amplifier, and that in B represents the BJT as current controlled current source, a current amplifier. Now, another model, it is called T model. So far the discussion in this session is about pi model. Now we enter into another model, T model. Two slightly Different versions of T model of BJT are shown here. Let us compare these two models. One resistor is here, another resistor is here. So both are carrying single resistors, and one current source, controlled current source is in A. In B also one current controlled source, but the source in A is GMVBE, whereas the source in B is alpha IE. Base collector emitter. Similarly, here also base collector. The circuit in A is a voltage controlled current source representation, and that in B is a current controlled current source representation. These models explicitly show the emitter resistance Re rather than the base resistance R pi featured in the hybrid pi model. Now here are shown another two models. These are hybrid pi small signal model in its two versions with R not included. So in A one model, in B another model. Let us see the difference. Resistance, another resistance R naught, another resistance R naught. So R pi, R naught are common. And in A current source is there, it is GMV pi. In B also a current source is there, but it is beta IB. In A it is voltage controlled current source, in B it is current controlled current source. With this we come to an end to the current session. To recap, in the present session, the focus is on pi equivalent circuit. This is mainly meant for high frequency operation, small signal operation. It is associated with four resistors, two capacitors, and one source. Different parameters that are there in the circuit. They are all defined and described. Hope this session is useful to you. We meet again in another session with a new topic soon.